Scaling Up Nation, are you looking for precise liquid level monitoring? Pyxis Labs' new radar level sensor series has you covered. With accurate monitoring up to 50 feet and wireless Bluetooth configuration via the Pyxis app, our sensors offer unparalleled convenience. Plus, LoRa technology enables long-range data acquisition. Experience the future of level monitoring today. Water professionals deserve better tools, and Pyxis Lab delivers. Go to scalinguph2o.com/Pyxis. Once again, that's scalinguph2o.com/PYXIS. Pyxis, because water professionals deserve better. Three industry titans, Masters Company, Radical Polymers, and MFG Chemical, have joined forces to create your ultimate one-stop shop for your water treatment needs. We're talking over 60 years of Masters Company's expertise in private label products and cutting-edge test kits. Radical Polymers' game-changing Inisha additives, and MFG Chemical's custom manufacturing prowess. These American companies are bringing you top-notch quality and reliability all under one umbrella. From blending and ultra-concentrates to specialized polymers and custom solutions, they've got you covered. And with multiple AWT Supplier of the Year awards between them, you know you're getting the best of the best. Ready to revolutionize your water treatment game? Head over to scalinguph2o.com/MFG. Once again, that's scalinguph2o.com/MFG. Trust me, you'll be glad you did. I know you can't wait for the AWT convention taking place November 11th through 15th. While you're there, be sure to stop by and see the whole gang from Masters, Radical Polymers, and MFG Chemicals at booths 200 through 208. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm your host, Trace Blackmore. Nation, on the way driving into the office this morning, I saw the Goodyear blimp. How old were you the first time you saw the Goodyear blimp? Well, the airport that's in between my house and the office, it is not the Atlanta airport. No, it's a smaller county airport called Briscoe Field. And there it was getting ready to launch the Goodyear blimp. And it just brought back some childhood memories. And I looked into the Goodyear blimp. And do you know that this year marks the 100th anniversary of when they first started launching the Goodyear blimp? So I don't know if you've ever gone up in a rigid airship filled with helium. I have not. I really don't have any desire to, but definitely if somebody invited me to do that, I would definitely say yes. So if anybody has any way to do that, I will not turn you down. But it just got me thinking of all the things that we kind of have from our childhood that we don't think about very much. And then we see something and it brings back all of these memories. And hopefully we have more positive memories than negative memories. But we all have memories. We all have a past. And it's my hope that we use that past as not where we're going, not as a limiting ceiling on the things that we can do, but no, what are the experiences that we've already had? And then how do we use those so we can accomplish what we want to accomplish next? And we use it as history, not as a limiter. And folks, I am sure there has been something in your life where you said, I can't do that because of this. Now, one of my mentors, Aaron Walker, you know him as Big A. He's been on this podcast several times. His mom taught him that couldn't do it, but could did it all. And he said she used to say that to him all the time. And that was just his mindset. Hey, I can't even think the word can't, because if I can't do it, I'm right. And that's what the mindset is. As long as you don't think you can't do something, you can do whatever it is that you want to do. Now, I'm not going to build a rocket ship and fly it to Mars and fly it back. I do not have that expertise. So I'm going to say I probably can't do that, but that's not a goal that I want to do. If there's a goal that I actually could do, and it should be hard, if it's hard, I'm going to stretch myself. And then by stretching myself, I'm going to become better in that process, and I'm going to get so excited when I accomplish that goal. That's what I'm talking about. And if I say I can't do it because it's hard, or if I say I can't do it because it's inconvenient, or if I say I can't do it because I don't know how, I can solve all of those things, and that would be an amazing accomplishment. So I want you to watch your language this week. How many times do you say the word can't? And I want you to instantly change your language. If you say, I can't do that, I want you to take stock of those. Are you choosing not to? Because if you choose not to for a reason, that is fine. But if you are just throwing that word out there as a limiting factor, that is not okay. I want you to consider that and make sure you consider everything that you put your mind to. Otherwise, you might say the word can't. All right, nation, I am hoping that you are keeping up with all of the great things that are going on within the water treatment community, like the 2025 SOCMA Summit and annual meeting taking place in San Antonio, Texas. Now, this is a group that's all about business leaders in the specialty and batch chemical sectors. Now, we have a lot of suppliers. We have a lot of friends that listen to the Scaling Up H2O podcast, that this is a perfect place for them to attend. And if they want to learn more about that, or if you want to learn more about this, go to scalinguph2o.com. And that is taking place October 21st and 22nd. Also taking place October 15th through 17th is the American Boiler Manufacturers Association is having their first ever Women in the Boiler Industry Symposium in Minneapolis, Minnesota. Folks, this is open to everybody. And I'm betting that this is probably going to be an event that really takes hold. So maybe you want to make sure you are at the very first one, and we are going to make sure that you have all the information that you need by going to scalinguph2o.com, going over to our events page. Also, mark your calendars for December 2nd through 4th, where the American Waterworks Association is having their North American Water Loss Conference in Louisville, Kentucky. We're going to have all of that information for you by going to scalinguph2o.com. And of course, all the things I did not mention are going to be on our events page. Make sure that you are taking time to plan where you are going to be. You never know what you're going to learn. You never know who you are going to meet, but you are not going to do any of those things if you don't plan to be there. And of course, many of you are planning on going to WEFTech. It is just around the corner, September 29th through October 1st in Chicago, Illinois. So, nation, if you are there, spread the word about the Scaling Up H2O podcast. Let everybody there know that there is a podcast for industrial water treatment. And while you're there, if you find something interesting, if you find a new product, if you find somebody that just has the best theories, the great white paper, go ahead and go to our show notes page and let me know who that is or what that is, because I would love to talk about it on this very podcast. And nation, somebody I know you love to hear from each and every week is our friend James McDonald. So here is a brand new segment of What Do You Know?
Hello and welcome to What Do You Know? The game show where we find out what do you know about industrial water treatment, drop by drop. So pump up your brain, take out that test kit of knowledge, and prepare to answer this week's question on What Do You Know? Today's question is, Back in the day, what was the treatment used for corrosion inhibition in cooling water systems that was banned around 1985 in the United States from widespread use due to its toxicological impact? The answer is chromate. While it was an excellent corrosion inhibitor and its yellow color often made it easy to monitor, chromate's ban helped push the industrial water treatment industry to develop many of the treatment chemistries we have today. I'm James McDonald, and thanks for playing along with us. Stay tuned for next week's episode of What Do You Know?
Thank you, James. And Nation, if you're not playing along on our social media, make sure you're following us on LinkedIn, and you can play What Do You Know before Friday, and you might even win the coveted pole position on our announcement saying that you were the first one to answer the question correctly. But the only way you can do that is by playing along on LinkedIn and then, of course, listening on Friday's podcast release. Well, Nation, one of my favorite things to do is to meet new people and interview them on this podcast. And that's exactly what we're getting ready to do. Here's the interview. My lab partner today is Matheus Paschoalino, Senior Business Development Manager and Microcontrol Subject Matter Expert of Solugen. Matheus, thank you for joining us on the Scaling Up H2O podcast today.
No, it's my pleasure, Trace. Thank you for having me.
Well, I am super excited to talk to anybody that's developing things for the industrial water treatment community. A lot of times we just get the hand-me-downs of other industries. You guys are going out and figuring out what are the issues that we are having. How do we make those things better? And that's what we're going to talk about today. But I'd love to learn a little bit more about you and share with the Scaling Up Nation about yourself. What does your day-to-day look like?
Sure. I'm a chemist by training, so I'm originally from Brazil. So I started my career there. And since my undergraduation, I used to work with wastewater first. And after I moved to the other applications in water, and I started my professional career at Nauco in Brazil as R&D. So research is where I could touch on the cooling towers, pilot cooling towers, and membranes and pulp and paper, some other applications. After some years, I decided to leave the lab. So I figure out that I like to be in front of customers and trying to solve their problems. So I accepted a position at Dow Microbial Control, so the Dow Chemical Company on that moment. And I spent about 9 years at this business, not just in Brazil. So I was relocated to the US in 2019, just before the pandemic, by DuPont Microbial Control. So my business went to DuPont when they did some mergers and acquisitions on that time. During that time, so I could enhance or explore my knowledge on the my microbial world, so much more with my prior job as corrosion inhibition, scale inhibition, so I could really go deep on use DNA analysis, for example. I accepted the job at Solugen about 3 years ago. As on that moment, I was the tech service manager for Solugen. And as you mentioned, they were developing some really cool new molecules, and they already had some good lab trials or bench trials, and they were needing somebody to do the scale up of this. So we need to do some pilot cooling towers, to do some field trials. So that's why I joined Solugen and came back to my cooling tower, the cooling tower world after some years focusing on microbial control, especially in oil and gas applications. So right now, after these 3 years, I think we could do a good job, and the technology is totally commercial for most of the applications right now. And as you mentioned, I could also now use my microbial control specialty that I developed here to another project that they discovered that's enhancing biocides. I think we will talk about this later.
And I believe you're referring to the polyhydroxycarboxylic acids. Did I say that correctly?
Correctly. Yeah, I think we used to describe this in a general way. We can call PHCs here to avoid saying all the long name.
That's definitely easier to say.
Exactly. So this is what we are producing nowadays. So we use basically corn syrup as a raw material, and we oxidize these sugars to these polyhydroxy carboxylic acids. So at the end, we will have a mixture that I can control the ratio among, for example, monoacids and diacids. And each ration or each cut of our process may have an ideal application or different performance depending where you apply. So I spend a lot of time finding these new applications. So not just in cooling towers, but going to other areas as well. And I think the process itself is really interesting. What really makes Solugen differentiated. So it's a really unique process. So it's a proprietary unique process that we call as a bioforge, but the process is a chemi-enzymatic. So we use both traditional metal catalysis and enzymatic catalysis. So we use enzymes to make chemistry. And this is pretty cool because we like enzymes can do chemistry pretty well. So you really can target, for example, groups that you want to oxidize or you want to remove, for example, for a molecule. You can do using the right team, the right technology. You can use like to develop a right strain of microorganisms to produce the right enzyme you want. And combining the enzymatic oxidation with the traditional metal oxidation that we also can optimize the metals we use, we can target the final polyhydroxycarboxylic acids. So this is what we produce nowadays. As I mentioned, we have different cuts. This is produced today in Houston, Texas. We have a plant producing about 10 KTA, so 10,000 metric tons per year of these materials. And it's already commercial, already in hundreds of cooling towers in the US and also starting exploring overseas. So this chemoenzymatic process will give us some nice advantage on the environmental side and also on the cost side. So this process, as the enzymes do chemistry so well, the yield is pretty high. So we are talking about over 96% of yield from the raw material to the assets at the end. So basically, we don't have a waste or a byproduct. So it's practically total conversion. And this causes the products be validated as a carbon negative. So we consume much more CO2 since the corn grow, for example, and in our process, then we have the emissions. So at the end, we have this benefit as well and validated by a third party. So for the customers or the regions that value that, we could generate, for example, these reports and help, especially when we are replacing traditional chemistry like phosphonates or azole. So we can compare, for example, how much CO2 a phosphonate production release. If you replace, for example, 1 ton per year of your phosphonate by our chemistry, you probably are saving or avoiding, for example, 2-3 tons of CO2. So we can do these calculations really, really quickly. And another advantage is the cost. So as the process is so efficient, I don't need to have like a final chromatographic steps in my process to purify. It's the first plant in Houston without gas emission, for example, authorization or liquid emission. It's practically the raw material is converted to the final product.
Matheus, would this replace regular chemistries or enhance regular chemistries that would be in our products now?
I think it depends on the formulation. I would say both. So for phosphonates, for example, HEDP. So HEDP in these typical organic formulations, we have generally for what we call the light duty market. So we'll talk about like hospitals, HVAC systems. When you have, for example, your HEDP, you have PBTC, You have our azole, your polymer, your PTSA. We already proved we can totally replace the HEDP on these formulations. So when HEDP is more in the formulation as a corrosion inhibitor, for example, we can replace by our first generation product, because this first generation product is a Nordic corrosion inhibitor. So we really can replace HEDP and show that we can create like a low phosphorus, so half of the phosphorus, total phosphorus formulation, and equal or better performance at the end, totally replacing HDP. Remember, you still have the PBTC there to deal with the some of the scale part. So this we already proved and is commercial over the US, but we also can enhance many chemistries. So I think we are really good enhancers of any other, for example, chelator. So not just in cooling towers, we are excellent chelator, especially for iron and other metals. So this chelation capacity gives us some advantage, for example, on the azole. So when we talk about azoles as yellow metal corrosion inhibitor, azoles are expensive and they are toxic at the end. So there's a lot of pressure of azoles right now. So we discovered that when you have like free copper, this is pretty known, especially after COVID, that they need to flush with a lot of oxidizers. We used to have a lot of water with free copper. This free copper can be like deactivated or chelated by the azole. So you are expanding your expensive azole with free copper, so you need to overdose. So we have a customer, and we did a nice trial with a customer of us in a famous university on the East Coast. So they used to have about 1.5 ppm of free copper, and the typical azole concentration that around like 3-4 ppm maximum. Like I'm talking a mixture of TTA, BZT, and some specialty azole. This 4 ppm was not enough to deal with this free copper, plus to control the corrosion in the heat exchanger, right? So what they did was, so they need to have like an adjunct drum delivering plus 8 ppm of azole, so total 12 ppm of azole, to deal with this free copper and control corrosion. So I have some talk to people in New York, for example, that they have cases where they need to dose 25 ppm. So it's really where you see the water treater bleeding. So it's really expensive. So what they did in this case was they removed this adjunct drum of azole that was delivered 8 ppm, and they replaced but our first generation PHC and dose it together. So they kept just the 3-4 ppm of azole and dose our product together. So what we discover is we can go against the free copper in a quicker kinetics, in a stronger complexation constant than the azole. So we can save your azole at the end. So you don't need to overdose anymore. So a much better cost product. So you save your expensive products. So that was when we figure out about this azole enhancement. And we had another customer who tried, what if no copper is in the water? If I use your product with no copper. So this was for more heavy duty. So we are talking about petrochemical plants, and the results were pretty good. So and you can see in some of my presentations, the heat exchangers, for example, it looks really good. So in some way, these materials, they can clean the surface and favor a great azole film on the copper surface. So even if you don't have free copper, it will enhance your azole. So you can use less azole at the end and save you not just on money on the azole, but also on the discharge as well. So this universe I mentioned before, they already were like deviating the blow down of the cooling tower to wastewater treatment. So they didn't need to pay an extra cost, and now they are able to discharge in the municipal treatment back without paying extra. So there are many advantages on this part. And we have other cuts of our process. So I mentioned chelators. So in oil and gas, for example, we have a more, I would say, simpler product that chelates iron pretty well. So if you already work with EDTA or citric, for example, we can boost these chemistries a lot. Like one plus one equals to three, for example.
So you mentioned HEDP. You said it will replace HEDP, but not PBTC. Did I get that correct?
Correct. So for light duty, so these are our organic formulations, we are just able to replace HEDP. You still need some chemistry to deal with the scale part. We are just play on the corrosion part here. So we are really good anodic corrosion inhibitor. If you remember the crisis on phosphonates around 2021, 2022, this was exactly when we did the commissioning of our plant. So it was Thanksgiving of 2021. So that really helped us to sample many AWT customers on that moment. And because they were like struggling to get phosphonates, they really tried and tried in pilot cooling towers, could find some customers willing to try. And that was where we get our first customers on the cooling side. And even when the phosphonates came back, they kept the treatment. So nobody gave up on the system because they really liked the performance and the cost. We have another like approach that I would say on the heavy side as well. So on the heavy side on the industry, when you typically have the stabilized phosphate formulations or programs, like you have the orthophosphate, the pyrophosphate. We also have an ideal chemistry, but it's not the first generation. So the first generation is our chemistry that is richer in monoacids. So this is what we consider ideal for the HEDP replacement and azole enhancement, for example. When you go to heavy duty, and we test this a lot in our PCTs, you need, like, we are talking about very high heat fluxes. You need a more stable chemistry on this harsh environment. And our second generation that is richer in diacids performs better for this. So we prove we can, for example, reduce the orthophosphate by half of a typical program and increase performance. And so we like to be very conservative on the way we do, to not overpromise anything. So we like to do, we start with the lab trial, we start with light duty. Now we are going to have duty first on low phosphorus. I know the holy grail is going to the no phosphorus. I think every big company nowadays have their own program. For sure, you can combine with metals, you can combine with acids. So we have an idea of neutral phosphorus. We just published this on this winter issue of CTI. So right now was probably last month. An idea what we call neutral phosphorus is when we can enjoy the native phosphate that's already in the water. So when the municipal treatment systems add phosphate, that's pretty common in the US. When you cycle up this phosphate, you can have like 1.5, 2, 3 ppm of phosphate. And our program will be no phosphate, so zero phos, but we will enjoy this small amount of phosphate on the water to help the treatment. So we propose this approach on this paper, is where we combine our second generation chemistry, the more rich in diacids, with some acids like polyaspartic acids. So we really try to go hard, so not using any metals on this bench scale trial, at least, just to show you, is really promising. But if we are able to use metal, it is really synergistic. So I think we have some prior papers on AWT, probably 2021, 2022, where we show like 0.8 ppm of zinc, for example, with this chemistry is really, really, your corrosion rate goes really down.
And I believe you've made those papers available to us. We'll make sure we have those on our webpage so people can follow along. One of the things about HEDP is you can test for it. How do you test for this product?
Yeah, we still have a gap on this. So we can test in our lab. We use liquid chromatography. So if you have a sample, you can test. But we did a lot of study to prove we are not deactivated by, for example, oxidizers. So I think you can imagine we are talking about a so conservative industry. We are talking about products that are there for decades. So it's really tough to get the chance to replace this. So what we did was we started going to AWT like before my time, 2021, 2020, and learn about what the customers care and now what their words. So I can comment the words of AWT community, for example, was, okay, you are saying you are giving me a bio-based chemistry and you put this in my cooling tower. Oh man, I don't like this. This probably you fool my cooling tower of biofilm. So we need to prove that we are not a bacteria food. So we did many cooling towers showing, for example, two cooling towers side by side, one with our chemistry, one with HDP, and both consume the exactly amount of bleach, for example. And always the counts are under 10 to the third. So we have all this really documented, we presented in 2022. And another thing we test is test with oxidizer. So we test this chemistry with bleach, chlorine dioxide, bromine, brominated as well, hydrogen peroxide. And we already knew about that because if you see the way this chemistry are produced, when we do the oxidation of the sugars, we co-produce hydrogen peroxide. So this actually was one of our first products that we used to sell in the past, but right now we reuse in our process. So these acids, they are so resistant to oxidizer because they are generated inside a soup of oxidizers at the end. So they are already pretty oxidized chemistry. So we did many tests. So if you use PTSA to target, it's really, really stable. We don't see any deactivation.
Now, you mentioned using this as an azole synergizer. I'll use that word.
Correct.
So being able to put a smaller amount of azole in, but still being able to test for azole, does that mean that the product's actually working before the azole and leaving that into the solution? Can you explain that for us?
Yes. If you have both chemistries at the same time in the water, we will act faster than the azole on the chelation or of iron or any heavy metal that will be like causing any problem on the azole deposition or forming the filming, for example. We can do this really quickly. So in a very strong constant. So you can continue using your azole, measuring azole. Some customers measured when they have free copper, the soluble copper or not as well. But you are correct. We are acting before the azole.
One of the issues we deal with when you mention using an oxidizer like bleach is typically we do have some more free copper into the system. What have your studies shown when using an oxidizer as a primary microbicide and enhancing your product with the azole?
So when you use chlorine dioxide, for example, in this test I mentioned for the university, they were using chlorine dioxide and they were using this blend of azoles. So we see no difference in performance of microbial performance on that time. No extra consumption as well. The oxidizer. So the oxidizer is not consuming our chemistry. It's pretty resistant. But what we learned in other conditions is when you use the non-oxidizer. So this is pretty interesting. Is a big part of my job today as a SME in microbial control is proving that we could also have another interesting multi-functionality of this chemistry that is we call biocide potentiator. But this is more for non-oxidizers. We have one data with oxidizers, but it's more on wastewater. So we don't see much synergy with bleach or the chlorinated ones. But our second generation, I present this as well on AWT. We prove when they use like peracetic acid, PAA, for disinfection, we can really be synergistic our second generation. So really increase the kinetics, for example, and the disinfection rate. On the non-oxidizers is where I spend most of my time today, not just in cooling, but in oil and gas. We discovered these chemistries Similar to the approach we do with the azole and free copper, we discovered that biocides are really, really overdosed because of deactivation. And this is a common thing on the market. When you go to oil and gas, it's easier to explain because of the type of chemistry, but I can try to correlate to cooling. For example, we have a biocide very common in oil and gas that's called THPS. So it's not very common in cooling, but in the label, cooling is there at least. But it's really common in oil and gas. It can be used as a biocide and it also can be used as a iron control chemistry because it chelates iron pretty well. So as it chelates iron pretty well, when you have a lot of iron sulfide because of this sulfate reducing bacteria in oil and gas, anaerobic, you dose your THPS. If you want it acts as a biocide, you need to overdose to compensate the interaction with iron sulfide first, and the remaining residue will act as a biocide. So you always need to overdose. When you co-dose our chemistry together, again, we go against that iron and iron sulfide first, and you only need to dose what you need to dose as THPS. So you don't need to overdose. So this we prove first with THPS, and we start to investigate with other biocides. So we test with glutquats, DBNPA, and they work in different ways, I would say. THPS is the best combination, but it works with all the other biocides. It works with Bronopol, TTPC. We test over across the board. And what is interesting is it seems to have an ideal ratio biocide PHC according to each condition, each water, each microbial population, for example. So you need to optimize to find the sweet spot because if you overdose, you don't see any problem. And this is very important to emphasize, even when you are replacing HDP, you never see any problem if you overdose by mistake our chemistry. But we see a plateau. So you start like seeing increasing performance, we start to see a plateau. So we don't increase performance anymore. So probably is because the amount of iron in the water, the amount of metals in the water, will go against these inorganic interactions first, and you can save on our chemistry. So I just remember on the HDP part that we touched before, is a big advantage that the customer says to us beyond the cost competitive, that is cost competitive, is green, is bio-based, is biodegradable, is in these typical our organic formulations, you don't have general pH control, right? So you allow the traditional stabilization by the alkalinity there. And when using HDP, you really need to have like a good control of your chemistry because you don't want to overdose because you start to have calcium phosphate hydroxide precipitation, especially if you have peaks of chlorine, for example. HDP we know can be degraded by bleach, PBTC much more stronger. And we could prove this that when you use our chemistry replacing HDP, you open this window a lot. So the water treated don't need to be like looking every day on the cooling tower because you don't have HDP anymore. So you can even cut the polymer by half because of that. Since you have less chance of calcium phosphate, you can cut your polymer by half. So this is another advantage I just remember.
You mentioned that when you were at AWT for the first time, everybody wanted to have you prove that it wasn't bug food, it wasn't going to create more biofilm. How did you prove that?
Yeah, so when I arrived at Solugen, they only had like the traditional corrators in bench corrators. And we started to go through WT. We figure out all these pretty specialized communities. So is it possible to arrive here just with lab data? So we need to do some investment. So we really invested in our own pilot cooling tower systems. So we have two cooling towers in north of Houston, close to the Bush Airport. So really like warm region. And I really like that cooling towers because it's almost real, I would say. It's not it's not just a pilot. So if you go to the most of cooling towers, they are inside a lab. So they are under some controlled environment. So our cooling towers are in the yard of our consultor, for example. So it's totally susceptible to bugs, wind, birds. So everything that can happen to our real cooling tower can happen to our cooling tower. So we have two cooling towers side by side. I think not so big. I think they are probably around 35 liters, the basing. We have pictures on the our presentations. And we really invested on putting like a really experienced consultant to deal with this. They have heat exchangers, so we can put carbon steel, we can put stainless steel if we want to see, for example, scaling. They have cameras taking pictures every 4 hours, so we can have a video at the end. All automatized with like ORP controlling the bleach. We started with PTSA in a portable fluorometer, so it works pretty well for that. But really good, a coupon rack, really complete. And we decided to do this first trial. So let's do side by side. We always like to do like cooling tower 1 is the Solugen cooling tower or the program. The cooling tower 2 is the benchmark. So we always we do that. And we need to pick a water. So a chemistry water. This is one of the challenges we have. So you talk to people in Chicago, they would like to use Lake Michigan water. You talk to people in Houston, they prefer like the Texas River water. So we used the local water at that moment. It was a well water. And we started the treatment. So we started to see bug growing. So it is a water that's susceptible to microbial contamination. And we started to treat with bleach side by side. So the bleach containers were like totally independent for both cooling towers. And we could control like minute by minute the volume. And we published this in 2022 in the Vancouver AWG. So you can see the graph side by side, both cooling towers, that is practically the same. And for sure, we monitor with deep slides all the time, showing as well that it is not. And we start to have the adoptions after that. So we don't know everything that the customers do with our chemistry, but we have like great customer that we know that know the industry better than us, and they are pretty happy. So we don't have any complaint, I would say, in the last 3 years. So no complaint on bug grow. I just have like the opposite. So people bringing me pictures of coupons, like thousands of coupons, and equal or better than the incumbent chemistry.
I want to ask you about heat concerns. As it sees hotter skin temperatures, are there concerns like there would be with calcium phosphate?
When you're talking about like the light duty side, you see a lot of advantage on that part because you have much less strain on calcium phosphate by using our chemistry. And we proved this on our PCT, stressing the system. So we have a paper on CGI that I think we called something like using of these pHs in stressful conditions. So we use probably the double of a typical heat flux in the light duty. And we use like peaks of chlorine of 1.5, 2 ppms. So really stress the HDP. And you can see HDP or calcium phosphate totally covering both heated specimen, the carbon steel and the stainless steel. The carbon steel at the end, the corrosion was lower because you totally cover with calcium phosphate. For sure, it's something you don't want in your heat exchanger. But in our cooling tower, we just had like a small patch of calcium phosphate. So we did XRD to prove, for example, it was calcium phosphate and calcium phosphate hydroxide. And that's what I was talking before, that the customers really like this ability to, I don't need to pay much attention on chlorine dosage or the HDP dosage anymore, because if I overdose by mistake, I only have better corrosion rate at the end.
You mentioned earlier about its chelating effects. Can you go a little bit deeper into that?
These materials, so when you talk about the molecule itself, so polyhydroxy carboxylic acids. So you imagine I have a traditional carboxylic acid, you have the carboxylic acid groups, mono or diacid, and I have a lot of hydroxyl groups in the chain of the carbon chain. These hydroxyl groups play an important role. So if you go to EDTA, for example, and you count for just the acid groups or the groups that will do the chelation part, you know the stoichiometric part, right? You know how much they can calculate. The most crazy part of this PHCs is substoichiometric. Because of these hydroxyl groups, if you just count for the acid groups, you'll be crazy because they can calculate much more than they should because of the hydroxyl and the conformation they can be. So there is also a conformation part. So these materials sometimes they can close a ring, they can keep it open, depending on the metal. And we have a case, for example, removing copper or removing aluminum, for example, from other streams, for example, organic streams, that we keep reusing this chemistry, reusing, and it keep chelating and removing aluminum, for example. It's because of this. So we are not just talking about the acid groups, but the hydroxyl groups play an important role here.
My dad used to joke that EDTA stood for eats the damn tubes away, and you had to be careful with how you fed that. Do we have to be careful with how we're feeding this product? Will it go after certain metals, and we need to look out for that?
Not really, man. So that's another advantage. So I have customers, I don't have details because it's their data, but they use this chemistry even for passivation, for example. So in closed loops, they use like more concentrated than the typical ppm. So when we replace HDP, we are talking about the same level of ppm active, but people are using concentrated to do passivation, and is really good passivator of cooling towers. And that is some of the ideas we got on the white rust part as well. As we know, we need to do the passivation, and sometimes customer cannot wait or don't want to wait 1, 2, 3 months. So they want to go faster. So we discovered, and we just presented on AWT last year, steel bench data that both generations can help control white rust. So on this galvanized system, we tried really hard. We tried like using high pH, high alkalinity, soft water that we understand is really worse to produce white rust. And well, I think we used just PBTC or just azole as a baseline. We really can boost this, so can reduce by half in this aggressive condition the corrosion rate. But the best for sure is the second generation. The second generation, we really could reduce, I think, almost 90% from the baseline. So it was really good. So we are willing to find a partner to test in the field. We still didn't test in the field.
Matheus, if somebody wanted to learn more about this product, and as I mentioned, we'll have all of your white papers on our show notes for this episode, how can they contact you? What should they do?
Sure. I think they can reach out through LinkedIn or by email. Probably it's easier to look how my name is written. So it's Matheus with H, Paschoalino with CH. But probably you can figure out on the podcast title, right? And please reach out to me on LinkedIn. And my email is exactly my name, just a dot in the middle, Matheus.Paschoalino@solugen.com.
Well, thank you for coming on the Scaling Up H2O podcast. Like I said, I love it when people look specifically at our industry and say, hey, how can we make something better? A lot of times we just get some leftovers from other industries. So thank you for really caring about our industry and trying to bring some new technology in. Before I let you go, I do have a few lightning round questions for you.
Okay.
Matheus, if you could go back in time and talk to your former self on your very first day as a research and development chemist, what advice would you give yourself?
I think I would say try to go to the field as most as you can. So leave the lab a little bit. The lab is important, but try to go to the field. All the knowledge, the main knowledge is there. So I think one field visit stands for like hours and hours in the lab. So you learn so much, and that's what I like.
What are the last few books that you've read?
Yeah, I used to read in phases. Like sometimes I am dedicated to one subject. I really like philosophy, so and like political themes. So the one I still finishing is I Must Betray You. It's from Ruta Sepetys. I think it's a bestseller. Really tells some interesting stuff about the Romania. So in the communist era, so how crazy was that spy network that they had there. So really interesting for people who like that type of subject.
When Hollywood writes the script about Matheus Paschoalino, who do you want playing yourself?
And that is tough, man. I think Mark Wahlberg.
There we go. He'd be honored to get that part.
Yeah.
Last question. If you could talk to anybody throughout history, who would it be with and why?
Yeah, I think I would not go so long in the past. I probably would try to meet there's a grandfather that I never met. So because he died really when my mom was pretty young. So I probably would try to meet him.
Well, Matheus, thank you for coming on the Scaling Up H2O podcast, sharing a bit about your technology and helping the industrial water treatment community.
It's my pleasure, Trace. Thank you for having me.
Scale Up Nation, any of the resources that were mentioned today will be on our show notes page. So make sure you're always tuning in to the episode. You're listening to the episode, but then you are going to scalinguph2o.com and then you are looking for all the resources that we have for you that make this podcast just come to life, because we have all the materials that our guests mention. We also have some extra things just to make your learning a little bit easier and a little bit more fun. Did you know that we do a discussion guide for each and every podcast episode? Now, we've done that for a few episodes in the past, but we've started doing that for every single episode this year. So maybe you want to take this episode and you want to have a discussion with your team. We make that super easy for you. You can simply go to our show notes page, get that episode discussion guide, and it tells you everything that you need to talk about. Of course, you can add your own commentary to that. We just want to get the conversation started for you. And you'll be amazed at how much people lean in and give you their opinions and also things that they want to know more about. There's so many company leaders that I'm hearing from that are using these discussion guides in their regular meetings. There was somebody that didn't have a regular meeting. They heard that other people are doing regular meetings, so they started doing a regular meeting. And each and every meeting, they talk about the podcast. Now, we try to make that easy for you with the discussion guide, and we've got so many other tools that you can use not only to help with your meetings, but help with your learning. Because as we all know, this is an industry that is always changing. There's always something new. There's always something next. And if we're not staying on top of our game, this industry will pass us by very quickly. And I will tell you, I have been in this industry for decades, and a lot of things are very slow to change. But when I look back to how things were done when my dad was teaching me this industry, it is just head and shoulders above technology-wise where it was back then. Folks, I remember having to replace the microchips in controllers for Y2K. This was a huge issue. All of our controllers in all these school systems would not work after the year 2000. So January 1st, 2000, maybe that was 2001 the problem was. The controllers were going to stop working. And I don't know why they couldn't work thinking that was 1901. I don't know why that was a big deal. But anyway, it was a big deal. And I remember we had to go out and we had to disconnect the controllers. We had to take the old processor out, the old chip out, and we put a new one in, and then we had to reprogram it. I bet you I did that no less than 200 times because we had these school systems. This was a lower grade controller, and that's what we had to do. So we don't have to do that anymore. Hey, we were smart enough to figure out, let's put a 4-digit year on the dates, and we won't have that issue. By the way, that was the upgrade on that chip that I was replacing. So we went from that to now AI interpreting our data and now making decisions on sites on certain pieces of equipment. We went from that, not having 4 digits in a date, to Skynet controlling our water treatment programs. Nation, if you are not keeping up with the technology, if you are not keeping up with the new information that's out there, this industry will leave you behind. And I'm sure glad that you are listening to this podcast because I love bringing it to you. But if you're listening to this podcast, you are staying up with technology because I'm trying to bring that to you. You're helping bring that to me so I can bring that to you. Same thing with information, same thing with guests. I'm going to give you the plea that I always do. If you have something that needs to be on this show, please go to scalinguph2o.com, go over to our show ideas page and let us know what that is, because we want to make information exchange as easy as possible. We have to know about it and know who has it in order to do that, and that is where you come in. Nation, thank you for listening to this episode. Of course, we're going to have a brand new one for you next week. Until then, make sure you are staying on top of your game and maybe download one of those discussion guides. Have a great week, folks. Collaborate and thrive. At the Rising Tide Mastermind, collaboration is key. Work alongside like-minded professionals who are eager to share insights and strategies. Together, we achieve more. Join us and experience the power of collaboration. To find out more about the Rising Tide Mastermind, go to scalinguph2o.com/mastermind. Once again, that's scalinguph2o.com/mastermind. Find out if the Rising Tide Mastermind is right for you.